Moving on now to chapter 3 on the pure year 1 course, which is on equations and inequalities. We start this chapter off by dealing with simultaneous equations, which you dealt with at GCSE. Now with simultaneous equations, what we need to do is multiply each of the equations by a number so that either the coefficients of x or the coefficients of the y are the same. Most of the time at GCSE you're taught to make the coefficients of x the same. But in this situation, we're better off making y's the same because we only need to multiply this second equation by 3, and then you'll have 3y on both of the equations. In fact, what I'm tempted to do here is actually multiply it by minus 3. So then I've got plus 3y on both top and bottom. So if I multiply it by minus 3, I'm going to get minus 9x plus 3y equals minus 69. I'll rewrite the first equation underneath, and then 3y, take away 3y is 0, because this is the whole point, is to get rid of one of the unknowns, so just subtract the equations. Minus 9x minus 2x is minus 11x, minus 69 minus 8 is minus 77. Minuses are obviously going to cancel. If you divide by minus 11, the minuses just cancel, so just forget about the minus signs. Divide by 11, x equals 7. If you take that value of x and substitute into either the first equation or the second equation to work out the other unknown, let's do it into the top one. So if x is 7, 2x is 14, 14 plus 3y is 8, and then if I take the 14 across, 3y is negative 6, divide by 3, y is negative 2. So you've got your values for x and y. What you can then do is check that they're right by substituting into the second equation. 3x, 21, y is negative 2, 21 minus 2 is 23, so you know they're correct. On to b, and in b we'll make the x's the same, so I times the first one by 3 and the second one by 2, then I'm going to get 12x and 12x. So I get 12x, take 15y is 12, and times in the second one by 2, 12x plus 4y equals 50. Again, I want to subtract. Minus 15y minus 4y is minus 19y. 12 minus 50 is minus 38. Again, a minus and a minus is just going to cancel. Divide by 19, y equals 2. Take that, smack it into the top one, say. 5y will be 10. So 4x, take 10 equals 4. Smack that across. 4x equals 14. Divide by 4. X is 14 over 4, 702, 3.5. You can write it as a fraction or leave it as a decimal, it doesn't make any difference. Checking the bottom one. 6 lots of 3.5, well, it's going to be 21. 2y is 4. 21 plus 4 is 25, so you know it works. In example 2, we use a different method. This method is called elimination. In example 2, we're going to use a method of substitution. The substitution is where you make either x or y the subject of one of the two equations, and then you substitute it into the other equation. So this is the only way I've got y on its own. Well, y, 1y. So if I just rearrange that, move that over, 2x equals 1 plus y, move the 1 back, y is going to be equal to 2x take away 1. And I'm going to take that value of y and substitute it into here. So in fact I need 2y, so 2y is going to be 4x take 2. Or you can put it in brackets and substitute in, really doesn't matter. But if I put 2y in, so 4x plus 2y, so that's 4x take away 2. 4x plus 4x is 8x, minus 2 moves across as add 2, so that's minus 28. X is going to be minus 28 over 8, so that's 14 over 4, 7 over 2, it's 3.5 again. Minus 3.5 rather. And then we know 2x equals 1 plus y, so x is minus 3.5, so 2x is minus 7. So minus 7 equals 1 plus y, bring that back, y is negative 8. And again, you can check those in the second equation. So 4x is going to be minus 14, 2y minus 16, minus 14 minus 16 is minus 30, so you know it works. Okay, have a go now, exercise 3.